Okay, day 6. Day, not days, but you get the picture. There'll be a test next class, so Monday, and I'll kind of go over that at the very end here. Um, Sink and float with alcohol. I think I went over this last time, but basically, if we have our water line from 2 classes ago, and let's say I create an alcohol line, then there'll be objects in between them. In this case, it will float in water because it's below it, and then sink in alcohol. And then we could do this for all sorts of things. I could do one for vinegar, which is slightly more dense, or oil, which is slightly less dense, and so forth. And then we can kind of have like a profile of where objects will sink and where they will float in various different liquids. So you can kind of keep going with the idea that we started with water and whether things sink and float in water. Apparent weight, the boat problem. I think everyone got that, but the boat problem is basically if you're displacing fluid inside the boat, you're going to displace fluid outside the boat. It doesn't matter which one, so the water level's never going to change. Like I said, I think everyone got that, so it's not an issue. Net force. Okay, so apparent weight. What is apparent weight? Basically, it's the net force or weight that an object experiences in a fluid due to buoyant force. Anytime you have a fluid, let's make my color blue. There's always going to be a buoyant force that pushes up on the object. And when that buoyant force is greater than the gravitational force, it floats. If it's not, it sinks. And so this later on leads to the Archimedes principle, which is the mass of your object is equal to the mass of the displaced fluid, which some of you got not all that close to and the numbers. Maybe I just need more equipment or newer equipment, but yeah, it's what it's supposed to be. The object should be equal to the mass of the fluid. And this is Archimedes' principle, and you can use this to do all sorts of stuff, but one of the main things you can do is to see how much weight like a ship will carry. It can be used to prove that an iceberg, you only see about 11% of it above the waterline. It's supposed below the waterline. And yeah, there's a lot you can expand on. It's kind of beyond the scope of this class, but yeah, a lot of cool stuff with Archimedes. Boron apparent weight. Let's say we considered a shredded 200-pound man. So let's say it's Wolverine from what is it? X-Men Origins. Why shredded? Because they need to be very dense. My example here. In air, the apparent weight of the man is around 200 pounds, because that's what they see on the scale. In water, the apparent weight is going to be less than 200 pounds, because the buoyant force exerted by the water on the man is significantly more than the buoyant force exerted by the air on the man. And then in alcohol, it's somewhere in between. So alcohol has a density in between air and water, closer to the water side, but the apparent weight is definitely going to be less than air. You're going to weigh less in a vat of alcohol, but you're going to be more than water. And then in heavy water, okay, what is heavy water? Well, you know that hydrogen has a proton in the center and an electron that orbits it. This is known as protium. Well, there's isotopes of hydrogens. One of them is deuterium, which has a proton, a neutron, and an electron. And then the much more rare tritium, which has a proton, 2 neutrons, and an electron. Heavy water uses those isotopes, mostly deuterium, because deuterium is like 0.02% of what's found in nature. But this is kind of cool because this is, I don't know what liquid this is. I guess we can call it water, but I don't really know. This is protium, so your typical hydrogen ice. And this is, we'll say, deuterium ice. Close enough. And see, it sinks. That's because it's heavy water. It's used in a lot of nuclear application. But anyways, I chose it because it has a density of 1.1 grams per milliliter. The apparent weight is less than water, alcohol, and air in that order. And I needed the guy to be dense, i.e. Wolverine, because most humans are around 1 gram per milliliter. We needed that person denser than that to make sure that they would still sink or float or weight, basically be able to step on a scale. Okay, test 1. There's going to be around 11 questions, intrinsic and extrinsic properties. You'll have one on apparent weight, like that I just went over. Simple unit conversion, so like, I don't know, 10 Spam cans is equal to 2 rotator cuffs. I don't know what that is. And then if you have 8 Spam cans, how many rotator cuffs do you have? Something like that. You're going to have to do a graph with slope and analysis. Don't forget to title and label your axes. Maximum deviation. Don't forget to study that. There's a small practical part where you have to find like the density of some object or something along those lines. And then an operational definition. The study guide, while more limited than your future study guide, can be found on Blackboard, kind of going over what I just said. As long as you watch all the videos and kind of look over your notes, it's not a terribly difficult test. Your future ones are generally the harder ones, particularly 2 and 3. But yeah, make sure you look over the study guide, and I will see you today because I didn't post this yesterday. Sorry about that. Or rather, do this yesterday.